February 8, 2025. Mount Etna's ancient crust begins to fracture. Scientists are stunned as glowing, unknown material erupts, not found in any volcano on Earth. Seismic alarms warn of an impending collapse, with pyroclastic flows hurtling at 140 kilometers per hour. Has Etna's core unlocked something that could trigger a disaster unseen since the Mediterranean's last great tsunami? The clues point to a threat growing faster than anyone predicted. The eruption's aftermath left scientists staring at a puzzle no one expected. Amid the familiar rivers of molten rock, a new substance pulsed with an unnatural, electric glow. It wasn't the deep orange of basalt or the glassy sheen of obsidian. This was something else. Its radiance visible even through thick ash, its color shifting from blue-white to a faint, almost ultraviolet shimmer as night fell across Etna's slopes. Geologists on the ground, accustomed to cataloging every mineral the volcano could produce, found themselves at a loss. Field spectrometers failed to register any known signature. The substance stayed blisteringly hot for hours, refusing to cool at the rate expected for volcanic glass or lava. Even after being isolated from the main flow, it held its temperature, radiating heat that warped the air around it. Attempts to measure its composition with handheld XRF analyzers produced only error codes. Samples collected under strict protocol showed no resemblance to sulfur, andesite, or any known volcanic byproduct. When researchers tried to compare it to Etna's historical mineral database, one of the most complete in the world, there was simply no match. Local volcanologists, many with decades of experience, described the scene in quiet disbelief. One researcher's field notes read simply, "Alien. No other word fits." The material's persistence fueled speculation. Was it a product of extreme pressure from deep within the mantle? Or had Etna tapped into a previously hidden reservoir? The glowing mass sat on the cooling plain, defying explanation, its surface rippling as if alive. Every attempt to document its properties only deepened the mystery. In the days that followed, the substance became the focus of urgent scientific debate, drawing teams from across Europe to Etna's slopes. The question was no longer just about what the volcano could do, but what it had become capable of unleashing. On February 8, 2025, the seismic network at Mount Etna registered a pattern that had not been seen in years. Instead of the shallow, scattered tremors that usually accompany magma movement near the summit, a dense swarm of earthquakes began pulsing deep beneath the southeast crater. The first quakes struck just after midnight, their epicenters clustered between 8 and 14 kilometers below the surface, far deeper than Etna's typical activity. By dawn, over 40 distinct tremors had been logged, some strong enough to rattle windows in the villages on the volcano's lower slopes. Seismologist Dr. Elisa Conti, who has tracked Etna's rhythms for more than a decade, reviewed the real-time data as the swarm intensified. She noted that the frequency of events was doubling every 6 hours, and the depths were marching downward, not up. In her words, the pattern was unmistakable. Something was forcing its way through old, stable rock. The energy was moving into zones we'd always thought were locked. By the afternoon of February 8th, the Italian Civil Protection Department raised Etna's alert status, citing anomalous seismicity of uncertain origin. Automated alerts pinged cell phones across Catania and neighboring towns. The official bulletin described unprecedented earthquake swarms and called for increased monitoring of the southeast crater, where the tremors were most concentrated. Instrument arrays captured harmonic tremor signatures, long, low vibrations that often signal the movement of magma or superheated fluids through tight channels. Yet the seismic traces didn't match any previous eruption cycle. Instead, the quakes seemed to echo and fade in chambers that had always been considered solid. The network's algorithms flagged the data as an outlier, prompting Conti and her colleagues to convene an emergency call with the National Geophysical Institute. Within 24 hours, the number of recorded quakes surpassed 120, with several registering above magnitude 3.0. The swarm's epicenter shifted again, this time tracking a path toward the southeast flank, the same sector that collapsed in the distant past. For the first time in years, Etna's scientists faced the prospect that the volcano's deep architecture was not as stable as once believed. The data drove home a single conclusion: the situation was no longer routine. Something fundamental had changed inside Mount Etna. At 11:23 a.m. on June 2nd, 2025, Mount Etna unleashed a paroxysm unlike anything in its recent history. The first explosion shattered the summit's silence, sending a column of ash and incandescent rock soaring more than 6,500 meters into the sky, twice the height of the volcano itself. Within seconds, the upper plume billowed out, blotting the sun and casting the city of Catania into a midday dusk. Satellite feeds tracked the ash cloud as it drifted east, disrupting air traffic and blanketing the Ionian coastline with fine, abrasive grit. On the ground, the eruption's violence became clear. A caldera wall gave way, releasing a torrent of superheated gases, ash, and shattered rock. Pyroclastic flows burst from the breach, racing down the southeast flank at speeds topping 140 kilometers per hour. In less than a minute, these flows carved a 2-kilometer path through Lion Valley, incinerating everything in their way. Observers describe the advance as a moving wall, opaque, roaring, and unstoppable. Local monitoring stations recorded temperature spikes and seismic surges as the flows thundered past, their heat melting snow and ice in a violent flash. Eyewitnesses reported a deafening roar followed by a pressure wave that rattled windows 20 kilometers away. Emergency alerts pinged across the region, warning of falling ash and urging residents to shelter indoors. The eruption's intensity forced civil protection authorities to evacuate mountain villages and close roads leading to the summit. For hours, the volcano continued to pulse, each new blast sending shockwaves through the fractured crust. Scientists watched in real time as the summit's structure shifted, its stability visibly compromised by the force of the paroxysm. With every passing minute, the scale of the event grew, pushing Etna's already unstable summit toward a new and unpredictable phase. Before sunrise on February 13, 2025, the landing pad at Catania's Civil Protection Base buzzed with tension. Dr. Luca Ferri, a volcanologist with years on Etna's slopes, checked his insulated sample kit one last time. Pilot Sofia Rinaldi ran through pre-flight checks, her radio alive with updates about shifting ash clouds and tremors. The window for a safe ascent was narrowing. At 6:42, the helicopter lifted off, climbing into turbulent air streaked with sulfur haze. Rinaldi kept low, weaving between columns of ash that twisted up from the southeast crater. Ferri scanned the instruments. Wind shear warnings flashed, and the ground below shimmered with residual heat from the paroxysm days earlier. Approaching the summit, the team spotted their target, a patch of glowing material isolated on the fractured rim, still radiating heat that warped the air. Rinaldi brought the helicopter down in a swirl of dust, landing gear sinking into loose ash. Ferri jumped out, boots crunching over unstable ground. Seismometers strapped to his belt ticked higher with every step. He worked quickly, using insulated tongs to pry a chunk of the glowing mass into the containment cylinder. The sample's surface pulsed blue-white, heat fogging his visor. Radio chatter spiked. "Ground is trembling. We have to go." At 6:55, Ferri clambered back aboard. Rinaldi throttled up as a tremor shook the landing zone. Ash and debris battered the rotors. The helicopter clawed skyward, barely clearing a fresh collapse that swallowed their footprints within seconds. Later, Ferri described the escape as a blur of noise and shaking, like the mountain was trying to keep us. Once clear of the summit, the team radioed their coordinates and secured the sample. The landing zone where they'd touched down collapsed minutes later, erasing any trace of their presence. For Ferry and Rinaldi, the risk was calculated, but the consequences were real. A reminder that on Etna, the line between science and survival is razor thin. At precisely 8:12, the laboratory's containment alarms erupted in a piercing wail. The sample container, just delivered from the field, had been transferred to the main analysis bench. As the technician disengaged the final seal, a dense vapor burst upward, shimmering with the same unnatural glow seen on the mountain. Within seconds, the air monitors spiked. The vapor spread fast, drifting across the lab in a toxic wave. Emergency protocols snapped into place, red lights flashing as the evacuation order sounded. The technician staggered back, hands burning beneath double-layered gloves. Later, medical records would confirm chemical burns, blisters forming almost instantly along the exposed wrist where the glove had slipped. In testimony, the technician described the sensation as unlike any acid or caustic they'd handled before. It felt like my skin was dissolving. The vapor had weight, it clung to everything. Security footage captured the chaos. Researchers scrambling for the exits, some coughing, others shielding their faces as the vapor curled along the floor. Sensors in the ventilation system recorded a sudden spike in corrosive aerosols. Automated doors sealed the lab, halting all airflow to contain the spread. The building's intercom repeated evacuation instructions as first responders arrived in full hazmat gear. Outside, the injured technician was rushed to a mobile decontamination unit. The burns were treated on-site, but the lingering effects, numbness, persistent redness, remained for days. Inside, the glowing sample continued to emit vapor, defying standard containment. Attempts to cool it failed. The lab's filtration systems, designed for volcanic gases and industrial toxins, proved useless against this new threat. Analysis was suspended. For the first time in years, the facility declared a full lockdown, freezing all research on the material. The event forced a reckoning. Etna's latest gift was not just a scientific puzzle, but an active hazard. Any further study would demand new protocols, and a level of caution rare even for those accustomed to working on the edge of disaster. Inside the sealed laboratory, hope for quick answers faded fast. The glowing sample, now at the center of global attention, refused to cooperate with any standard test. The team started with Raman spectroscopy, a go-to tool for identifying minerals by their molecular vibrations. But the results were baffling. Instead of clean, recognizable peaks, the spectrometer returned a jumbled spectrum, signals that overlapped, shifted, or simply disappeared between scans. Next came X-ray diffraction, the gold standard for mapping atomic structure. The machine cycled through its routine, bombarding the sample with X-rays, waiting for the telltale diffraction pattern. Instead, the printout showed contradictory lattice signatures, one moment hinting at a silicate glass, the next at something metallic, then nothing at all. Each method contradicted the last. By mid-morning, the lab's chief chemist called a halt. With containment protocols already stretched thin and no meaningful progress, she issued a Level 4 safety directive. No direct handling, no further invasive tests until external review. The glowing mass remained locked in its isolation chamber, still radiating heat, still refusing to cool. Researchers stood outside the glass, studying readouts that offered no clear answers. Even attempts to measure the surface temperature met resistance. The usual thermal cameras overloaded, while contact probes failed to register a stable reading. Frustration grew as each analytical path led to a dead end. The sample's vapor continued to defy filtration, corroding the edges of containment filters and leaving a faint residue that resisted chemical neutralization. Every protocol, from gas chromatography to electron microprobe analysis, stalled or produced noise instead of data. One technician scanning the latest batch of error codes muttered, "It's like the laws of physics don't apply." With the clock ticking and the world waiting for answers, the research team faced a hard truth. None of their trusted tools could unlock the mystery. The laboratory's stalemate forced scientists to look beyond traditional analysis. If the material wouldn't yield its secrets under the microscope, maybe the answers lay deeper. Beneath the volcano itself, where new imaging campaigns were already being planned. Moontomography teams, led by Professor Amina Haddad, began scanning Etna's southeast crater just days after the eruption. The imaging arrays, designed to track subtle shifts in density, returned a result that startled even the most seasoned researchers. Where previous scans had shown dense, unbroken rock, the new data revealed a vertical zone of strikingly low density. This column extended far deeper than anything recorded in Etna's extensive monitoring archives, plunging beyond 30 kilometers, well past the limits of the upper crust and into the mantle itself. Seismic cross-checks confirmed the anomaly. Earthquake waves slowed as they passed through the zone, suggesting not solid rock, but a vast silent space with unknown contents. The feature was entirely absent in pre-2024 datasets, raising questions about when and how it formed. Haddad's internal memos described it as a missing core, a structure that defied established models of volcanic plumbing. The possibility of a direct pathway from the mantle to the surface unsettled the team. In the words of one specialist, if this column is real, it means Etna is tapping reservoirs we never thought accessible. Within hours of the eruption, the slopes of Mount Etna became a battleground, not just for scientists, but for competing visions of the volcano's future. Mining conglomerates, led by Teradyne, launched fleets of drones across the ash-choked landscape, scanning for rare earth elements and critical minerals. Procurement records and leaked flight plans showed their intent: rapid extraction, before any new restrictions could take hold. The discovery of a potentially unique mineral deposit drew these companies in with the promise of untapped wealth. But their presence on the volcano's fragile flanks ignited public fury. In Catania, the activist group Voci dell'Etna called for an immediate halt to the drone operations. Hundreds gathered in the city's piazzas, waving banners that read, "Hands off Etna," and chanting for the protection of the UNESCO World Heritage Site. Local civic organizer Alessia Romano stood at the front of the march, her voice amplified over the crowd. "This mountain belongs to all of us, our history, our safety, our future, not to profit seekers." The protests quickly gained momentum, forcing the Italian parliament into emergency session. Lawmakers debated a temporary moratorium on all non-scientific drone flights, while environmental lawyers filed injunctions to block mineral prospecting. The crisis had outgrown the realm of geology and entered the streets and chambers of power, where the fate of Etna became a test of priorities: heritage, community, and the right to decide what risks are worth taking. Weeks of failed laboratory analysis brought the investigation to a standstill. With the glowing sample locked behind glass, an international review panel gathered in Rome, hoping to break the impasse. Leading mineralogists, volcanologists, and chemists compared datasets, but every method, spectroscopy, diffraction, chemical assay, hit the same wall. The material refused to fit any known classification. No peer-reviewed paper could offer a definitive answer. The sample remained a riddle, its properties shifting with each attempt to pin it down. During the symposium, Dr. Maria Santoro, an archaeologist specializing in Mediterranean disasters, presented sediment cores from Sicilian coastal sites. Layers of marine sand deposited far inland matched the timeline of Etna's massive flank collapse 7,200 years ago. She described how entire settlements vanished beneath tsunami debris, their artifacts scattered by waves that swept across the ancient landscape. The parallels were impossible to ignore. Etna's current instability, paired with the unclassifiable substance, echoed the prehistoric warning etched in the earth. As the panel adjourned, the sense of unfinished business lingered. Answers remained elusive. but the risks were written in both the present and the past. On February 8, 2025, seismic records showed a dramatic shift beneath Mount Etna, marking the beginning of an eruption unlike any in recent history. For the first time, scientists report a glowing volcanic substance with properties undocumented in geological literature. Laboratory analysis has so far failed to classify the material, and a containment breach injured a technician, highlighting the unknown risks. Muon tomography and seismic imaging revealed low-density voids beneath the southeast crater, structures not present before 2024. Despite emergency government action and global scientific attention, the true nature of the new material and the risk of another catastrophic flank collapse remain unconfirmed. Historical sediment records prove that a collapse 7,200 years ago triggered a Mediterranean tsunami, reshaping entire coastlines. Today, Mount Etna stands at the intersection of urgent scientific inquiry, public safety, and historical precedent. The facts are clear. Unprecedented changes are underway, but critical questions remain unanswered.